Hello everyone, so we are back with Leetcode daily challenge. In today's problem we need to find the frequency of the most frequent element. So as in the question given, we are given an integer k. So k will be the number of operations we can do. Here operations mean to increment a number by 1, right? So we can take any number from the array, we can increment that number by 1. So that will count as a single operation. So we are given with the k operations and we are given with an array, and we need to do some operations and try to find out the frequency, maximum possible frequency of the most frequent element. So as in the question example given below, here we have 1 to 4 and the number of operations we can do at most is 5. So what we can do, we can take a target, like we can increment 1 by plus 3 to reach 4. We can also increment 2 by 2 to make it 4, and we can then have a maximum frequency as 3, right? So 1 will be 4, so here 1 will be also 4, 2 will be also 4, and 4 will be 4. So the maximum frequency of the most frequent element here 4 will be 3. So this is the optimal solution. So let us try to understand the question in bit more clear, like how can we find a approach to select what should be our target element. So for example, here in the question 1, 2 and 4 is given. So what should be our target element, like we should increment any number till which point, like what should be the element we are focusing on. So let us the optimal solution will have the target element should be belongs to nums array. Why I'm saying like that, target should belongs to the nums array. For example, let us try to here our optimal solution has 4 as the target element, right? So what if we take a element which is not present in the nums array? For example, if we take 5, right? So to make 4, like to make all the element as 4, for example, we make x element 4. We can make x element 4. Here here x is 2. We were able to make 2 element as 4. So if we take any element which is not present in the array, for example 5, then we need to have some extra x operations to make it 5, right? Because 1 will take x plus 4. Previously it was taking plus 3. Similarly 2 will take plus 3. So we will have we need extra x element to make it 5. And this is not an optimal approach, because these extra x operations can be used to make another element as 4, right? What if we took 3 as an target element, right? So if we try to take 3, then what will be there? We can lose a 4, right? As 4 was there, we can lose a single occurrence of 4. What if we have 1 2 4 4 4 4, and if we take 3, then this like we lose the occurrences of 4 because we just took a smaller element, because here the operations mean to increment, we cannot decrement the value, right? So we cannot take 3, we cannot take 5, we have to take any element which is present in the nums array. So this is the first first theorem, like we have to take the any number, the target element should belongs to the nums array, right? So another thing to notice is that to increment, like here we can only increment the value, we cannot decrement the value, right? So what we have to do, we have to, like for example, we have to make if we took 4 as a target element, then we can only select those element, like only we can only perform operations on those element which is smaller than 4. For example, we can only perform operations on 3, we can only perform operation in 2, we cannot perform operations on 5, 6, or any element which is greater than 6 4, which is greater than our target element, right? So since we can only perform operations in smaller element, so this is our target, and we cannot perform operations on our larger element. So you can make a thought like that we are following a sequence, like we are following a order, right? So what we need to do, we need to first sort the array to get the elements in a order. Like for example, here 1 2 4 will be the in order. If 5 is there, so 5 will be there. So we need to first sort the array. After sorting the array, what we need to do, we need to, for example, we have 1 2 4. what we need to do, we need to make a window, right? We need to make a window, and we will do some operations and count like what the minimum number of operation required to if we are choosing that number or not. For example, here at first we will choose 1 as our target element. So how many numbers we can make 1, right? We cannot make there are no elements smaller than 1, so we can only have a maximum count as like frequency as 1, right? Because we cannot do operations on a larger element. What if we choose 2? So when we will choose 2, what how many like in how many numbers we can do the operations? So we will have a left pointer, we have a right pointer. Right pointer is at 2, so our target element will be nums of right. And what how many numbers we can we can do operations. So here 1 can be incremented. For example, our k is given as 5, 1 can be incremented to 2, right? So we can easily increment 1 to 2. So how can we find we can increment or not? So for that we need to have a current, like current prefix sum, and we will add the like sum till the right index. So here the sum until the right index will be 3, right? Current will be 3. And if we make all the elements in that window as 2, our target element which is 2, if we make all the elements in that window as 2, what will be the like sum, like total sum? So total sum will be window size multiplied by the number itself 2, right? So for example, if there are 1 1 2 3 and our target element is 3 and our window size is 4, so when we will make all the element as 3, so what will be our total sum will be 3 4s are 12, right? And how many operations we need? We need to just subtract the prefix sum which is stored here in current by that total sum, right? So here the prefix sum will be 1 1 2 3 3 to 5 6 7. So we will subtract 7 from 12 and we will get 5. So we need 5 operations to make all the element as 3. You can verify like 1 need 2 operations, 2 operations and 1 operations. We need a total of 5 operations. So this is the approach. First we will take a target, and then we will have a prefix sum till that target, and then we will count like total size, like total sum, and we will subtract the total sum from the prefix sum to get the number of operations. And if this number of operations is greater than k, like the given value, then we cannot take that window size, we need to shrink that window size. So in that case we need to decrement, like we need to move the left pointer to right. So this is the optimal solution. So let us try to solve this solution in our Leetcode. Yeah. So at first, as I said, what we need to do, we need to sort the nums array, right, to follow our order. So at first we will sort the nums array. Nums dot begin, comma, nums dot end. So after sorting the array, what we need to do, we will take some pointers, like we will take a left pointer, it will be 0. We will take the maximum frequency as 0. We will then take a long prefix sum, and it will be set to 0. Like we are taking long because it can exceed the int size. Then what we will do, we will from the first index to the last index, we will try to find out whether that number can be our target element or not, right? So we will take a for loop. Int r will point as a right pointer, r less than nums dot size r plus plus, right? And then we will take the target as long target equals to nums of r, right? And then what we will do, we will add that number to our presum plus equals to nums of r, right? So after doing this, what I said that we will our answer will be like our maxi will be max of maxi comma the window size. So here the window size will be right minus left plus 1, right? And what if this can be only our answer when the window size is optimal, right? That means that the number of operations we need to do in that window is less than k. So while how can we find the number of operations? As I said, we will subtract the total sum from the prefix sum, right? So the total sum can be obtained from window size right minus left plus 1 multiplied by the target element, right? This will give our total sum. We will subtract the prefix sum from that sum and we will get the number of operations needed. So if this is greater than k, like if it is greater than the number of operations given, then we need to shrink our window. So our window can be synced by incrementing the left pointer, but we also need to subtract the number which is in the left, like which was in the left index. So we need to subtract that from the prefix sum. Minus equals to nums, sorry, minus equals to nums of left, right? Nums of left. Now let us try to return maxi and try to run this code whether it works or not. Return maxi. Yeah, it is working fine. Let us try to submit this code. Yeah, it is working fine. So thank you for watching this video. The approach is very much simple, but it does not came at once in our mind. We have to think about it, like how can we convert this solution into an optimal sliding window solution. So thank you for watching.